Hello, everyone, and thank you for joining us for today's session. My name is Askia, and I am one of the event planners for the Redmond Reactor Space. Before we get started today, I've got a few things to go over. So, if you could please take a moment to read our code of conduct. And basically, what that's saying is that we seek to provide a respectful environment for both our audience and presenters. We encourage engagement in the chat, but we ask that you please be mindful of your commentary, remain professional, and if possible, please try to stay on topic. We're going to be sharing useful links throughout the chat, so please keep an eye out for that. And we want to let you know that this session is going to be recorded and will be available on demand in about 24 to 48 hours. And that's going to be on the Microsoft Reactor YouTube channel. That brings us to today's session. It's scheduled to run approximately 30 minutes, and there'll be time for questions throughout. So with that said, I'd like to hand it over to Bill, our speaker for today, and let him introduce himself.
Hello, everyone. Thank you so much for joining or for watching. And my name is Bill Ayres. I'm an MVP for Azure AI, amongst other things, also Microsoft 365. And today I'd like to talk a little bit about building AI agents using Semantic Kernel. So when we say agents, we kind of mean something beyond a chatbot, something that's actually going to do something. And it'll be, I think, a fun demonstration and interesting to see. So just in case you're wondering what is Semantic Kernel, it's really an SDK or an API that you can use to build AI agents. And it's a sort of an enterprise ready solution as well. So I'm going to show how just using 100 lines or so of code, we can build something very useful, more than a chatbot that actually does something. Now, Semantic Kernel is actually available as an SDK in C# and also in Python and Java, not JavaScript, Java. But today we're going to use C# and .NET. So if you're from a .NET development background, this will be, should look somewhat familiar to you. So I'm going to do a quick demo. And if you want to try this out yourself, you can go to my GitHub on SPDoctor, and the repo is called BusyLight if you want to have a look at that yourself. Let me bring up Visual Studio Code, and this is the main program that we're using. I'm not going to go through this at the moment, but it's a C#.NET application that I've built. As I say, it's about not much more than 100 lines, well, less than 100 lines of code. I have a couple of other files as well, and we'll come to those as well. But first, let's just see what this does. So I'm going to do .NET run. And it gives me a prompt, and I can say, for example, hello, I'm Bill. And it should, I'm going to put my glasses on so I can see what I'm typing. Hello, Bill, how can I assist you today? I say, and I can say, what's my name? And the assistant says, your name is Bill, how can I assist you further? Now, if we just used a large language model on its own, it wouldn't know what my name was. So there is a history. It's remembering the previous conversation. Now, if I were to start this app again, it would, and I said, what's my name? It would say, I have no idea. I'm a large language model or something like that. So that's the first thing. It's got some memory. We can also say, ask it some questions. So I'll say, who won the World Cup in, what year should we pick? Oh, let's say 1966, just, any old date. And it comes back and says the 1966 FIFA World Cup was won by England. Okay, no need to mention that it's the only time that we've won the World Cup, but we defeated West Germany. So that's great. It knows a little bit of history. What if I say, where does Queen Elizabeth live? Then we get now we run into problems. We get a rather poignant reference to Queen Elizabeth lives at Buckingham Palace, but she also spends time at other residences, because this large language model was trained and up to about 2021, I think, or possibly 2023. Anyway, before, sadly, the Queen died, it doesn't know up-to-date history. Now we can fix that, and we can add something to allow it to go off to the internet and get newer information. But that's one of the drawbacks, is the large language model knows what happened in 1966, but not what happened in 2023. So let's look at the, one other thing we can do is we can say something like, what time is it? And again, a pure large language model can't tell you what time it is. It's just like a stateless mechanism that you call it, and it will look at whatever it's been trained on. It's been trained to answer questions helpfully, usually. The particular large language model we're using at the moment is GPT-4. And GPT-4 wouldn't know what time it is, but we've got a mechanism in this the tool that Semantic Kernel is going to call, which is why you see calling function there. That's logging the fact that it's called a time plugin, which can give me the current time, and therefore the assistant can return with the current time. Okay, let's see how that works behind the scenes. So first thing to note is we're using Microsoft Semantic Kernel on line 4 here. So this is the SDK that we're talking about. It's providing a layer of abstraction over some of the large language models and the way we interact with them. And I've also called a few other extensions and some other using statements. And then if you've used .NET to, say, build a website with ASP.NET, for example, you might be familiar with this builder pattern. So one of the things Semantic Kernel is doing is effectively acting as a dependency injection container, so that we can then pull in other resources and other tools. And then the deployment name I've got here is GPT-4. So let me just show you where I got that from. So this is Azure AI Foundry. So in Azure AI Foundry, which is part of Azure, I've provisioned a model. So there's something called a model catalog, which has a wide range of different models. That's one of them. There's a long list of models. It's got 35 different models that you can pick from. There may be others depending on what sort of licensing you have and so on. And they're not all OpenAI. There are others from other providers as well. So there's a wide range of models that I can pick from. And then what I can do is deploy them. So I can create a deployment. There are other ways of using Azure AI Foundry, but this is the way I've used, is I've deployed a number of these models. So I've taken the GPT-4 model and I've deployed that, and it's actually 613, which is quite an old, it's now probably nearly out of date now. And that deployment name is GPT-4. It didn't have to, the name could be anything, but I chose GPT-4 without the hyphen as the deployment name. And that's what I'm using in here to get at that model. And then I need the endpoint and API key. And again, that comes from the Azure resource that I've deployed, so that there you'll get the endpoint and API key. Obviously, I don't want anybody to be able to use this, and I'm not going to hard code my API key into this application, because that would be a horrible security risk. So so I'm at the moment I'm using an environment variable. Probably in production you'd want to have it in something like Key Vault or something like that. So that gives us access to that GPT-4 large language model deployment in Azure OpenAI. You can also use other models, or you can use the OpenAI models directly from OpenAI, not the Azure versions of them. So it's very flexible what you can use through Semantic Kernel, but I've chosen to use Azure OpenAI. Then we add Azure OpenAI chat completion, giving it that deployment name, endpoint, and API key. I probably would use an environment variable for the deployment name as well. I just wanted to hard code that so you could see it there. And then I've got some plugins. So we'll come to these plugins in a while, but one of the plugins is called the Time plugin. And a plugin is a way of just adding some additional capability to a large language model. If you've got a large language model that supports function calling, which GPT-4 does, then you can use this function calling mechanism. So how that works is, if I go to this file time.cs, this is the plugin. It's just a normal class. It's called class time plugin. It's not derived from some special base class. The only thing that's at all special about it is I've decorated the methods with these attributes. Kernel function tells it's a kernel function for semantic kernel, and then there's a description, and this is what the large language model uses to work out which function to call using this function calling mechanism. So it's quite a complex process. The large language model gets called once, and then it comes back, and then it says call this function, and then you call the function, and you then send something back to it. It's quite tricky to set up, but semantic kernel just takes care of all of that for us automatically behind the scenes. So that's a big win. It means we're able to use function calling, but you do need to make sure that the language model you're using supports function calling for this to work. So that's the plugins. We'll look at some of these other plugins in a minute, and then I'm going to do kernel builder build. So this is the builder pattern. And I've added a log filter here, and that's actually something I've written myself that will log the fact that we've called a function and what it did. That's how we were able to see when it called the time function. We were able to see that in the chat. And then we have this object called chat history. So this again takes care of all the managing the history of the conversation. So if I didn't have this chat history, then it would, when I said, what is my name, it would say, I have no idea. The large language model doesn't know. But when it calls the large language model, it calls it with all the preceding conversation, including the inputs and outputs, so that the language model knows the context of what it's dealing with. And so it's able to refer to things earlier in the conversation. Then we add a system message. So this is where we do a little bit of prompt engineering. So here I've said, you are a helpful assistant. You are not restricted to using the provided plugins and can use information from your training. Please explain your reasoning with the response. The reason I've phrased that like that is I discovered that over time they modify these models. I used to have this lines 34 and 35 in as well, and it says if the user doesn't provide enough information, keep asking questions. That worked great about a year ago, and then it started getting really chatty and saying, oh, am I really allowed to call this function, and things like that, which you don't really want as part of your chatbot. So I removed that and fine-tuned this prompt a bit to make sure that most of the time it just calls the function automatically without too much chit-chat and a bit like applications that sometimes say a little bit too much. Are you sure you want to click OK and things like that? So that sometimes requires a bit of prompt engineering to just fine tune the prompt. Then we call the get required service chat completion service, and this step here is to enable automatic function calling. So remember, it's going to call a function at the appropriate time automatically and take care of all that, but I have to tell semantic kernel that that's the behavior I want. So I say function choice behavior auto, and it will automatically do that. So two things that has to be there, and the large language model has to support function calling, which most of the newer ones do. Okay, then we start the conversation. There's the prompt user message read. It reads the user message. I just check if it's exit or quit, and I'm just going to end the conversation if you type that in. Otherwise, we'll add the user message to the history, and we call the chat completion service and stream out the results from it. And then the results themselves also get added to the history as well. So it knows what you asked it, and it knows what it replied. And that's pretty much how it works. And that's how we're able to get this quite effective chatbot working that can do things like tell me what time it is, which you wouldn't be able to do with just a large language model. Let's try a few more prompts. So let's look at, I've got another plugin here. So the plugins I've got are time plugin model. Well, I'm not going to use this one. I'm going to use calc plugin. So that's in this file here, calc CS. And I've built a sort of a calculator that can do arithmetic. So it's going to do, say, add, subtract, multiply, divide, powers and roots, and then I kind of lost interest, and we could go on. So it has those methods. These tend to take 2 arguments in addition to, so the time, I just say what's the time. This can take arguments, so divide, and so I can add a description not just to the method but also to the arguments or the parameters. So I can say this parameter is the number to divide from, and the number to divide by is this parameter, and that tells the large language model which one to use, how to use the parameters. So if I look at that one, we can say what is 200 squared, and it comes back and it calls the power function and say 200 squared is 40,000. Now I can also say what is the square root of 200, and it calls the root function. But an interesting thing happens here. Apologies for the confusion. There seems to be an error. The square root of 200 is not 40,000. The first time I saw this, I was absolutely amazed. I thought the large language model is checking the results of the function call, and it's saying my calculator's broken. It's like a bit like a human, I think there's a fault with this calculator. Well, let's try and fix it, shall we? So we go back to calc.cs, and well, let's find this root function. And it seems to think that this is wrong. Well, I think I'm going to get my development team working on that. Of course, my development team is actually GitHub Copilot. Let's do an inline chat here and say, I can say /fix. And it says, the issue is that the root method incorrectly uses math.power, which should instead use math.power number and 1 over number. Of course, because the mistake was it was the it's in the wrong place. Not that one. It's that's the power function. Right. So it should have been 1 over. Let's. I forgot to take the reciprocal when I did that. Let me just do that again. Fix. Oops. Can't type. Fix. And now it will. It's correcting the one I've put it. It's that one. This is the one. No, this is wrong. It's that one. That's the root function. It's the first time that's done that. So anyway, I can use GitHub Copilot to fix code that my large language model discovered when I tried to use that function. I thought that was really interesting, that the large language model has got your back when there's a bug in your function. I don't guarantee it's going to work every time, but it's looked at taking a square root, and it said that doesn't look right to me. You know, it should be something else. So now if we recompile that, it should work correctly. Let's see if that works. Since we've got a minute or two, I'm going to save that. That was root, wasn't it? It's always risky doing this when you're debugging live. I'm going to quit this, and I'm going to run it again. I'll just restore it, and then if we say, what is the square root of 200, it should be, what, 14 point something, shouldn't it? Let's see if it works this time. Square root is approximately 14.14. I use the root calculator, so it works now. Now, I've got a gadget called what is it called? Busy Light, which is this Quando Busy Light. It's intended for Teams, so it, you know, when you're in the middle of a call, it'll be red. So it'll be red right now because I'm in this call. Otherwise, it's green or something like that. It's just plugged in through USB. And I discovered there's an SDK for it. The SDK is and I've used it here. So I've got another plugin. So in my plugins, I've got this light plugin. And if we look at that, I'm using Busy Light. So I've found a NuGet package, which is the driver for this, the device driver for this over USB. And then I used their functions, and so I made a class light plugin, and the first function is called light on. I've got to have kernel function description, turn on the light with the required color. It's got 3 parameters. They are red, green, and blue. I actually discovered that there was a kind of a bug in the Busy Light SDK because they, for some reason, have it red, blue, green, which, you know, it's the wrong way around, isn't it? It should be RGB, red, green, blue. So I fixed that and called them. I can tell you it took a while to figure out what was going on there, but we got there in the end. And then I've got another one called turn off the light, which just sets the colors to zeros. And then there's a function called make the light flash, because the SDK has a blink function. That's the Busy Light SDK. So I can make it tell it to flash, and it stays flashing. Now I'm going to use something just to position the Busy Light device in front of the camera so that you can see it. I have to put it right in front because it's otherwise it's quite bright and you won't be able to see the color. It'll just look white. So I'll put that there. And then what we're going to do is go back to the application, and we're going to say make the light blue, and then automatic function calling, it will find the Busy Light function and should turn the light blue, which it does. So I'll make my screen dark but you can see it is blue. I can also say make the light azure, the color azure, and it makes it a sort of the turquoisey blue color. Now it can do things like make the light the color of grass. It's a bit more subtle, and it turns it green. Is it obvious that it's green? Difficult to tell, really. That is green. It's quite a light green, I have to say, but it is green. And I can say something really wild, like make the light flash like a Belisha, I think that's how you spell it, beacon. Those are those lights at British zebra crossings. Let's see what that one does. And it should make it turn amber and then off. I'm not doing anything. On. It goes off because they do actually flash amber. So that's pretty neat. So finally, I'll just do one more. I'm going to say make. This doesn't always work first time. Make the light the color of the shirts of the winning team at the 1966 World, still Belisha Beacon flashing at the moment, World Cup. Right. This will be interesting. So, now this sometimes happens. So, those of us who know about this will know that actually England do normally play in white, but we'll see. But Germany wore white, and it has a little think. That's the color. No, it's not. It was what you sometimes have to work at this. What color did the England team wear? What color shirts, I should say? What color shirts did the England team wear in the 1966 World Cup final? The light is now white. No, Germany wore white. What color did England wear? I wanted to. It is absolutely not going to. Let's see, what is it saying? It said they also wore white shirts. No, they didn't. They definitely did not wear white shirts. England wore red. Make it that color. Come on. Finally, it's done it in red. So it sometimes is an effort to persuade it. I think we could maybe improve the prompt, the system prompt. But anyway, and there you are. There they are wearing their red shirts. So I'll move that out of the way. It's amazing what you can do with 100 lines of code using Semantic Kernel. You can make some really interesting models that can actually do things and make things happen in the real world. So thank you very much. I hope that was interesting. I do encourage you to look at Semantic Kernel and maybe look at that code. So thank you very much indeed.
All right. Thank you so much, Bill. That was a great session. We definitely appreciate your time, and thanks to everybody for tuning in. We also would love and appreciate any feedback that you have in regards to this session. We put the link on the screen, the AKA link. And the most important thing is you'd want to enter today's event code, which is 25188. Once again, that is 25188. Thank you all for your time, and we will see you on the next episode.